All right, guys. So our topic today is going to be another form or another source of energy, one that you probably have also not heard of. I know several of you, before we learned about geothermal energy in the last class, that was definitely a new source of energy that most of the students did not know about. This is probably another source of energy that you may have never heard of, and it's called tidal energy. So if you do me a favor and at the top of your page, go ahead and title your assignment Tidal Energy Assignment, and we will get started. So first off, what should we already know to help us better understand what tidal energy is? Most of you took Earth and Space Science last year, as well as in 8th grade, where you learned about the topic of tides. So we should know that the tides are the daily changes in the level of ocean water, and it is due to the gravitational pull between the sun and the moon from the Earth. So if you look at this diagram here, these arrows represent the gravitational pull between different objects that are close to the Earth, thus being the closest object, the moon, which has the most significant impact on the ocean's tides. Remember, the Earth is 70% water, and that water moves. And it is a result of the fact that the Earth is spinning on its axis. It's also revolving around the sun. And at the same time, you have another object, the moon, which is revolving also around the Earth. And this acts like a game of tug of war, where both the Earth and the moon and the sun are kind of pulling on each other. And what that does is it creates tides or bulges of the ocean, where you see different changes in the water level. So if we know that the ocean moves, okay, if you know that there are tides, then that kind of gives you an idea of what tidal energy is. So go ahead and write the question down. What is tidal energy? Tidal energy is basically energy produced by the movement of the ocean due to tides or the gravitational pull. And as similar to wind, where the wind spins turbines, well, just take out the wind and add moving water. As water moves past the turbines that are attached to the ocean floor, this can produce electricity. So again, think wind energy, but instead of wind, it's actually water that is moving the turbines. So at this time, we're going to watch a short video that gives you a better idea of tidal energy. Okay, I want you to go ahead and watch that video. And when you're done, we'll go to the next slide.
Tidal power. Tidal power is a form of hydropower that converts the energy from the natural rise and fall of the tides into electricity. Tides are caused by the combined effects of gravitational forces exerted by the moon, the sun, and the rotation of the Earth. Tidal plants can only be installed along coastlines. Coastlines often experience 2 high tides and 2 low tides on a daily basis. The difference in water levels must be at least 5 meters high to produce electricity. Tidal electricity can be created from several technologies, the main ones being tidal barrages, tidal fences, and tidal turbines. Tidal barrages are the most efficient tidal energy sources. A tidal barrage is a dam that utilizes the potential energy generated by the change in height between high and low tides. This energy turns a turbine or compresses air, which in turn creates electricity. Tidal fences are turbines that operate like giant turnstiles, whereas tidal turbines are similar to wind turbines, only underwater. In both cases, electricity is generated when the mechanical energy of tidal currents turns turbines connected to a generator. The generator produces electricity. Ocean currents generate relatively more energy than air currents because ocean water is 832 times more dense than air and therefore applies greater force on the turbines. Tidal power is easy to install and renewable, having no direct greenhouse gas emissions and a low environmental impact. Because the ocean's tidal patterns are well understood, tidal energy is a very predictable energy source, making it highly attractive for electrical grid management. This sets it apart from other renewables that can be more unpredictable. However, adoption of tidal technologies has been slow, and so far the amount of power generated using tidal power plants is very small. This is due largely to the very specific site requirements necessary to produce tidal electricity. Additionally, tide cycles do not always match the daily consumption patterns of electricity, and therefore do not provide sufficient capacity to satisfy demand. That's tidal power.
Okay, so that gives you a little better idea of some of the pros and cons or advantages and disadvantages of tidal energy. So do you think that tidal energy, do we think that's renewable or do we think that's non-renewable? Remember, non-renewable resources of energy like coal and natural gas and oil, fossil fuels, will eventually run out. Tidal energy, we know that the moon is not going to all of a sudden like disappear, and neither is the oceans. So tidal energy is a renewable source of energy. So what do these turbines look like? You just watched a video that showed you some examples of the different types of turbines that there are. Here's an example right here, and it shows you just how large some of these turbines are that they're placing in the near the shoreline. And again, these can produce massive amounts of energy. This one right here is more of like a wind turbine. However, it spins almost in a horizontal fashion instead of a vertical fashion. And this one actually can like go up and down. So when the tide is not moving down here, they lift the turbine up. When it does start to move, they lift it down and it will begin to spin and create energy. Here's another type of tidal turbine. These almost look like an airplane propeller, and there's multiple turbines on this one. I don't even know what you would call that. I guess a tidal turbine. There's multiple turbines on the turbine. If that makes sense. That doesn't make sense. Let's move forward. So there's the point that I wanted to make here was that there's different types of tidal turbines and different shapes and different sizes, different types of blades. So what do you think some factors are that would affect the amount of energy that's created by tidal energy turbines? In other words, when we go back and look at these, let's say I wanted you to design a turbine to place in our tidal turbine test tank that you see on my desk in the front of the classroom if you're a traditional student. If I said I wanted you to design a turbine to come put in our tank, what are some of the factors that you would think affect the amount of energy created? So I want you to think about that, and I want you to make a list of 2 or 3, write those in your notebook. So at this time, pause me, think about it, write it, and then push play. So maybe you thought of these, maybe you didn't, but there's definitely the strength of the tide is very important. Not every place has the same strength of tides. We'll talk about that here in just a second. But definitely like the number of blades, if you look back here, these have 3 blades on the turbine, where this one looks like there's only 2, and this one looks like there's several blades. So the number of blades is definitely a factor that would affect the how much energy. Oops. Sorry, there was an announcement. So the angle of the blades absolutely are different. Those definitely would affect how much energy is created. Same with the length, like how long the blade is. And obviously the height of the water, like where are you going to put these tidal turbines? Are you going to put them on the bottom of the ocean? Are you going to put them towards the surface? Where are the tides the strongest? Okay, these are all factors that would affect how much energy would be created by tidal turbines. Now, so where can tidal energy be used? Well, first off, understand that there is a high and a low tide every day. So if you were standing on the beach for an entire day, you would notice that the level of the water is high at one point and then throughout the day begins to get lower. This is a daily fluctuation that occurs in our area. The difference in terms of the level of low tide and the level of high tide is known as the tidal range. You need to know that. Okay. And tidal energy would only really be used in areas that have large tidal ranges. Okay. So if you have a difference of like 20 feet of water here, that's a lot of water moving out and in every day, which would obviously produce more energy. It'd be like putting wind turbines in places that don't have lots of wind. Well, you're not going to create a lot of energy, right? So you wouldn't put a tidal turbine in locations where you really don't have a very large tidal range. Now, to give you an example of what the tidal range here in Pensacola is, I've provided what is known as a tide map or a tide chart for this area for Wednesday and Tuesday, or Tuesday and Wednesday of this week. Now, you'll look here that on Tuesday, which is actually yesterday, at 3:17, the tide or the water level was the highest at about 1.5 feet, right? Because it's about halfway between 1 and 2. Whereas as the day progresses, by 2:52 a.m., right, the water is at the lowest level. This would be low tide in Pensacola. So notice there's a difference here in terms of the tidal range. The difference between high and low tide is only about 1.5 feet of water. Now, that's not a lot of water moving. So this area that we live in, Pensacola, would not be a good place to do or to use tidal energy as a source of electricity because we just don't have a lot of moving water that would spin those turbines to produce enough energy for us. However, there are places like the Bay of Fundy here that do have large tidal ranges. So I want you to watch this video and observe what a large tidal range looks like. So you can see here throughout the day, the water is now retreating, is going out. So this is turning into a very low tide to the point where the water is completely out of this little canal. I mean, so right here, this would be low tide, right? Now, all of a sudden, the water comes back in over the course of the day, comes back in much faster than it went out. And then it reaches a level that we would refer to as high tide. This is a 50-foot tidal range. The Bay of Fundy, which is in Canada, has one of the largest tidal ranges in the world. They have a tidal range of over 50 feet. So you have a difference of 50 feet of water moving in and out every day. So this would be definitely a place that you would want to, to use tidal energy as a source of electricity. Now, there are disadvantages and advantages. Okay, we've been talking about this throughout our unit on renewable and non-renewable resources. Every type of energy source has advantages and disadvantages. Now, most of the advantages of the recent renewable energies that we've been learning about, like geothermal energy and now tidal energy, is that they are renewable. They're cleaner for the environment. They do not produce any emissions, so they're not putting CO2 or sulfur dioxide up into the atmosphere, right? But there are a lot of disadvantages to geothermal and to tidal energy and also to wind energy. So even though these renewable resources sound amazing, like, yeah, we would love to get our energy from tides or get our energy from the earth or from the wind or from the sun, but there are a lot of disadvantages to this sort of source of energy. And like obviously the number one disadvantage is you're putting huge turbines underwater. This is going to harm the environment of the ocean as well as possibly harm certain species that live in the ocean, like turtles and fish and sharks and anything that is in the ocean, when you have these massive turbines spinning around, it's going to make a difference. It's also very expensive. Okay. So there are several advantages and disadvantages of this source of energy. Now, at this time, what I'd like you to do is find a couple of more advantages and a few more disadvantages of tidal energy. I've given you 3. I want you to find 3 more. Okay, so you can find 3 more advantages if you can, 3 more disadvantages, or you can split it up and go 1 advantage, 2 disadvantages. But I want you to add 3 to your T-chart here in your notebook. Okay. Now, when you get done, okay, please bring up your notebook to me so I can stamp it and give you credit. And then when you go back to your seat, you should be now working on the Ed puzzle on tidal energy, which will give you a better understanding of this energy source. Thank you for listening. When you get done, like I said, come up to my desk, get your stamp, and then jump on the Ed puzzle, and you're done for today. Thank you.